Okay, hi everyone. Nadira gave a nice introduction of me. So I'll be doing the data modeling session. It's an introductory session, and it's a continuation of the previous one, what Vimukthini did before. Yeah, I'll start from the beginning. Yeah. Can everyone see my screen?
Yes, Vimukthini. Okay, we could. Yeah.
Right. Okay. Okay, so as you know, there are some steps that are involved in a data science project, and I'll be taking the part on incorporating machine learning algorithms. So the key steps in a data science project are to understand the problem, then to extract the data, to clean the data, then to visualize it and do some exploratory analysis, then to select the features, and to incorporate machine learning algorithms. So that's where I will be starting on, and I will test those models and I will show you how to deploy the models as well. Right, so when we talk about different machine learning algorithms, there are a number of algorithms from unsupervised learning, supervised learning, and other main algorithms, including neural networks, deep learning models, and so on. So the focus of today's workshop is this part. It's on regression. So we'll be talking about regression analysis, regression trees, and also we'll talk a little bit about neural networks, and we'll see how we can apply it for regression analysis. So the workshop workflow is like this. So I will first talk about linear regression. That will be a little detailed session, and then how to fit the model, how to evaluate the model, and how to check linear regression assumptions. And then I will move to regression trees, and I'll talk about fitting basic neural networks. And I'll talk a little bit about time series forecasting. So we have VAR models and MLPS time series forecasting. And finally, I'll show you how to save the model and to save the model predictions. Okay, so let me start with linear regression. So what is linear regression? So in statistics, linear regression is, we call it as a linear approach for modeling the relationship between scalar responses and one or more explanatory variables. So explanatory variables are the ones that we call as independent variables over x's. And the response variables are our y variables, or we can call it as the dependent variable. So when we have a single input variable, we can have simple linear regression. So that means we just want to say we want to measure the temperature. We say temperature average is equal to beta naught plus beta 1 times dew point average. So we predict our dependent variable temperature using an intercept, a slope, and an independent variable. So it's basically this line, the y equals mx plus c line that we all learned during our A-levels. And when it comes to multiple variables, we have multiple linear regression. So basically, we have dew point average and humidity average to predict the temperature. And for dew point, we have one slope variable, one slope value, and for humidity, we have another slope value. So I just put a chart here that I got from this source to show you what simple linear regression is and what this simple linear regression line looks like. Okay, so now I told you that we can fit a line, but how do we know the exact line that works? You say, how do we know that it is this line that works the best? It could be this line, or this one. So to determine which line fits the data well, we have a method which we call ordinary least squares. So in ordinary least squares, we find the best fit by minimizing the error sum of squares. So it sounds a bit scary when we hear error sum of squares. Then we can narrow it down. What is this error sum of squares, right? So what is an error? An error is the difference between an actual value and the predicted value. So now, for example, let's say this point here, the point that I'm pointing here. So if this is the actual value, this could be the value that the model predicts. It's the one that the black line predicts. And the error is the difference between these 2 points. It's simple, it's just the difference. And the sum of squares of errors is the summation of all the errors that we see in the data. So basically, we fit the line by minimizing this error sum of squares. Okay, so I'll move to the Google Colab notebook and I'll show you how to do it in practice.